Hello and welcome again to the Applied Business Statistics course. In this session, we are going to discuss the fourth part of topic 3 on hypothesis testing. In the last lectures, we discussed testing hypotheses around the mean and around the population proportion. In this session, we are going to discuss how to test hypotheses around the difference between two means and difference between two proportions. The idea behind testing hypotheses and the procedures and philosophy and the steps, the 6 steps which we mentioned in the earlier in the process of testing hypotheses remains the same for all testing hypothesis questions. We mentioned in discussing testing hypothesis around the mean and testing hypothesis around the population proportion, we mentioned 6 steps. And we will follow the same steps on all testing hypothesis problems in this session and in future sessions. Because we mentioned that testing hypothesis problem it is one of the most important problems in statistics, and we will keep talking about it in earlier sessions. Now, we are talking about the testing hypothesis for comparing two population means. If we have two population and we want to compare the means of the two population, are they equal or different, or the mean of this population, population A, is greater than or less than population B, or they are the same. For actually, we test whether we have significant evidence to reject a hypothesis that the population means are equal, or we do not have a significant evidence to reject that hypothesis. Now, we want to distinguish between independent samples and paired samples. If we have two independent populations and we draw independently from each population a sample, then we are talking about independent samples. So testing hypotheses for independent samples are different from testing hypotheses for paired samples. The procedures and the statistics are completely different. So the first step here, when comparing between two population means, is to know whether we are on the process of testing hypotheses for independent samples or paired samples. To know what are the independent samples, actually, we want to know the paired sample test. The paired samples is like we have one sample and we have two different measurements for each unit in the sample. Like, for example, if we have some employees and we have tested them for some area of interest, right? To measure their skills in some area, and we have given them tests before and after a training course, before and after. So we have two readings, two measurements, we have two samples actually for all employees. We have 20 employees and each employee have a score of the test before the training course and the result of the test after the training course. So we have two samples, one sample of the test scores before the training course, and the other sample is the score of the employees for the test after the training course. So in this case, the samples are not independent actually. They are dependent. Each employee have a score before this, before the training course and after. So are paired samples. We call them paired samples. Another thing like brothers, twins, the weight of the first twin and the weight of the second twin. So, and we have 10 twins, for example, and we have the weights of 10 twins. So they are not independent samples because each unit in the sample have another measurement for the brother, for his twin, for example. For another thing is the experimental animals, which we, after giving them some experimental things like some type of food, and we weight them before giving this food and after giving. So we have two samples of weights before and after giving them some specific treatment. The weight before the treatment and the weight after the treatment. That's also paired sample t-test or dependent samples. But in this, we will start here by independent sample. It's completely different populations and two completely different samples. They could have different even sample sizes. We might have, for example, from the first population, 10 observations, 10 units, and from the second population, we can have a sample of 20 units, no problem. But the paired samples, they have exactly the same sample size. You cannot have 10 and 20 from the two samples. You must have the same size because one observation from the first unit and another observation from the same unit and so on. So the sample for the independent samples, the sample size can be different. Right now, in order, and here another example, do males spend less on a newspaper than females? So we have two populations, males and females. Do males spend less on newspaper than females? So we want to have the average expenditure on newspapers by female and by females, by males and females, and we compare them to see who spend more, the males or females, on the newspapers. That's one example for this situation. Many examples, as long as the samples are not paired or not dependent, then they are independent samples. So males and females, they are not brothers, not husband and wife. They are not brothers and sister, or so on. So they are independent sample, and we have a sample from male population and a sample from the female population. And the parameters which we want to test, the parameter of interest, is mu1 and mu2. Mu1 is the mean of the first population, and the mu2 is the mean of the second population. If we want to test mu1 equals mu2, then mu1 minus mu2 will be equal 0. So they are the same. We can say mu1 equals mu2 or mu1 minus mu2 equals 0. For this, we can say that this is a problem of difference between two means. Hypothesis, we can call this problem as problem of testing hypothesis around two means or the difference between two means. Equity of two means or difference between two means, they are the same. So the null hypothesis, as usual, as we mentioned, always have the equal sign. So the null hypothesis, it's not mu1 equals mu2 or mu1 minus mu2 equal 0. The same meaning, right? That's the null hypothesis which we want to test. Against the alternative hypothesis, mu1 does not equal mu2. In other words, mu1 minus mu2 do not equal 0. So they are the same. Or this we call, well, this is the two-tailed version of the test. Two-tailed version of the test. If we have the non-equity sign, non-equal sign, it will be the two-tailed test. Or the one-tailed test could be mu1 is less than mu2, which means mu1 minus mu2 less than 0. That's the left tail test, or the right tail one is the mu1 greater than mu2. In other words, mu1 minus mu2 equals 0, which is the right tail test. Right? In order to answer questions like that, we must first estimate the parameter using point estimation of the parameters. We have mu1 and mu2. We know the point estimator for mu1 is x1 bar, mu2 x2 bar. That's the 2 point estimators for the parameters. So if the difference of them is the estimator of the difference is for mu1 minus mu2 is x1 bar minus x2 bar. That's the point estimator. This, as usual, when we talked about the testing hypothesis around the mean, we are now talking about testing hypothesis around the difference between two means. Then that's a point estimator, x1 bar minus x2 bar. Estimator for mu1 minus mu2, that's the parameter. And the estimator is a random variable and has, and like as any other estimator, has a sampling distribution. Actually, the sampling distribution for the difference between two means is a bit complicated. So we do not want to go through all the details of the difference between the details of sampling distribution of the difference between two sample means. So we will use Microsoft Excel in order to do the computation for us without going through all the details of the sampling distributions for the difference between two sample means. So that's the point estimation, the point estimator for the difference between two means, and has sampling distribution. We know it is a bit difficult, but so that's not important for us now to study it. So we want to set up the null hypothesis, which is mu1 minus mu2 equals 0 against any alternative of these alternative, which, as we mentioned, that either mu1 minus mu2 do not equal 0 or whatever. Right? So that has a sampling distribution, and we want to, without knowing the sampling distribution, the mathematical part, we go through the Microsoft Excel and calculate what? To calculate for first the estimate of mu1 minus mu2, which is x1 bar minus x2 bar. The Microsoft Excel give us the estimate, and it gives us the standard error of that estimate, standard error of x1 bar minus x2 bar, and also we have mu1 minus mu2 note. That's the hypothesized value. Hypothesized value, which is here 0. We either or k, but we do not need to talk about the non-zero difference. All the time we will discuss the zero difference, which not the difference is not any other figure like k or whatever. It is zero. All our questions we concentrate on the zero difference. In other words, the equity of the two means. So, without going into the details of the standard, the sampling distribution of x1 bar minus x2 bar. So we go to Excel and to calculate all the other things like standard error of x1 bar minus x2 bars and the p-value, the test statistic, which can be z or can be t, which, as we mentioned in earlier sessions, we mentioned z or t as long as the sample size is big, so they will be the same. So if it is t or z, it will be the same. And if we have the p-value, then if the p-value is very small and less than 5%, we reject the null hypothesis with 5% significance level. And if the p-value is big, more than 5%, we cannot reject the null hypothesis at 5% significance level, like the usual exercises in the last two sessions. So we have an example here, and we use Excel, the Microsoft Excel sheets to calculate the standard error and the p-value for this question. The example 10, which is automobile insurance companies take many factors into consideration when setting the rates. Actually, here in Gaza, all the rates are the same, but outside Gaza and Europe and America, the drivers do not have the same rate of automobile insurance. Good driver do not pay much for the insurance rate, and bad drivers who make accidents all the time, they are compelled to pay more rates than other drivers. Okay, it's not our problem here, but as we mentioned, automobile insurance companies take many factors into consideration when setting the rates. These factors include age, material status, and kilometers driven per year in order to determine the effect of gender. We will see whether, for example, males should pay more or less than females as insurance rates. We test this hypothesis. 100 males and 100 females, female drivers were surveyed. So we have a sample from males with size 100 and a sample of females, also 100 females. Each was asked how many kilometers he or she drove in the past year. The mileage or kilometers driven in last year for each male and female in the two samples. The distance in thousands of kilometers are stored in an Excel file. Assuming equal variances, when the variances are equal, the sampling distribution is different from the case. So, but we do not mention or we do not want to discuss the difficulty of sampling distribution in different situations, and this is one of these situations. So, assuming equal variances, can we conclude at the 5% significance level that male and female drivers differ in the numbers of kilometers driven per year? So do the males drive more than females or vice versa? That's the test which we want. So are they different in the number of kilometers driven? Are they different? So the alternative hypothesis will be not equal because we are not interested in uh, to see who is bigger, but are they different or not different? So the null hypothesis, as we mentioned, always equal. So males and females have equal means. Male and females have equal means of kilometers driven in the previous year, or mu1 minus mu2 equals 0, the same. Or the test which we want to the hypothesis which we want to test, or the alternative hypothesis is mu1 does not equal mu2, or mu1 minus mu2 do not equal 0. That's the alternative hypothesis, which the one which we test. Are they different or not? That's all. So we have all the Excel results here. All the Excel results. We are not interested in the detail, the mathematics of the sampling distributions and different versions and different assumptions, whatever. We have all these results. The result says we have means for male and female. The mean kilometers driven for males is 72, but for females 68, right? And they have variances 26.3 and 36.199, right? Observations, as we said, we have 100 males and 100 females. Pooled variance. The pooled variance is the variance calculated from both samples. We assume that they have the same variance. So instead of computing the variance from this sample or this, as long as the same, so we calculated from the 200 observations as the same, they have the same value. So that's we call the pooled variance. The pooled variance is 31.25, right? Hypothesized mean difference, the difference is 0 because we said mu1 not equal or equal mu2, or the difference mu1 minus mu2 equals 0. So that's the hypothesized mean difference is 0. Degrees of freedom is 198. They calculated in 1 minus plus mu in 2 minus 2, in 1 plus in 2 minus 2, but it's not important for us this thing now. So the t statistic or z the same, 4.49, and probabilities of t less than t is 1 tail. That's the p value for 1 tail, and the critical t for 1 tail is 1.693, which we want to compare with this. But we are interested in the 2 tail, not 1 tail, because we have 2 tail here, 2-tailed test. So for 2-tailed, the p-value is around 0, and critical 2-tailed t or z is 1.972, which much less than the t calculated or computed for t statistic or z statistic, which is 4.49. This is actually not exactly 0, as when you say this figure, that does not mean 0 exactly, but could be 0091, like that. So some zeros here and then other value. We put write it like that, but can't be exactly 0 here. But we say around 0. So the p-value is around 0, very small value, less than 1%, less than 1 point, not 5%. So as long as the p-value is too small, then we can safely reject the null hypothesis. This null hypothesis says the means are equal, so we are pro the means are not equal. So as the p-value for the two-tail is around 0, very small, so we can reject the null hypothesis at 5% significance level. Therefore, the mean of number of kilometers driven for female males and females are not equal. Actually, they are not equal. So now the other case, which is match pairs like husband and wife, twins before a training course or and after a training course, or experimental animals before a treatment or after treatment. So we have the two samples, paired samples in this case, and for this case, we in the match pair we take the difference because we have the same size for both samples because they are paired, so we have one number for sample size. We have sample of 10 observations from the first sample, so we must have other 10 observations from the second sample, and we take the difference. The difference is we usually treat it as one sample test, but the variable is now the difference, not the measurement itself or the observation itself. We take the difference and between the two samples from the two measurements for each observation, and we treat the difference as the random variable and has sampling distribution and continue to the test as if we are testing one mean for one population. And we, as usual, have null hypothesis mu1 equals mu2 or mu1 minus mu2 equals 0. And alternative hypothesis, which could be two samples, tail test or two tail hypothesis, like mu1 do not equal mu2, does not equal mu2, or mu1 is less than mu2 or mu1 is greater than mu2, which are one-tail hypothesis, right? In this case, mu1 minus mu2, we can estimate it by x1 bar minus x2 bar, which is the difference between two means, and that's d, and we call it d here in this case, d, and take the average of d and get the sampling distribution for d, and you do as the procedures step by step for 6 steps as usual. But here we will not go into the details for the for sampling distribution of the difference between two means, and we will use Excel. Another example here for the match pair. This example says, example 11, in order to determine the effect of advertising in the yellow pages, which telephone directory, book of telephone directory for merchandises, for services, for whatever. If you want, for example, a surgeon or dentist or whatever, any other doctor, and you look in the book of telephone directory, which we call yellow pages, and you find list of doctors or dentists or whatever, and you call anyone. You have the address and telephone number for that doctor. All services, not only doctor, even supermarket or whatever. if you want to buy something or want to sell something or want some service, anyone to come to make a service for you or whatever, you go to the book, that book which we call Yellow Pages. All right. Now, in order to determine the effect of advertising in the Yellow Pages, Telstra took a sample of 50 retail stores. Telstra is some company or whatever, took a sample of 50 retail stores and did not advertise in the did not advertise in the Yellow Pages. You have 50 companies did not advertise in the Yellow Pages. Yellow last year, but did so this year. The same companies, 50 companies, did not advertise in the Yellow Pages last year, but they advertised in the Yellow Pages this year. The annual sales in thousands of dollars for each store in both years were recorded. We have the annual sales for both years. The year which the company did not advertise in the Yellow Pages and the year which the company advertised in the Yellow Pages in thousands of dollars for each store. Both years are recorded. Can we infer at the 5% significance level that advertising in the Yellow Pages improves sales? So we want to test whether the average sales after advertising is bigger than the average sales before the advertising, right? So the alternative hypothesis is the difference is bigger than zero. The difference is bigger than zero. And that's the alternative hypothesis. But as we said, the null hypothesis always have the equal sign. So the difference is zero. The difference is zero. So we have two hypotheses. The null hypothesis, the difference is zero, and the null hypothesis is the difference is greater than zero. And we set up all the steps of this procedure, but we use Microsoft Excel as usual and got the following results. So we have means here 77 and 71, and we have the variance 403.876 and 313.3. And we have observations the same 50-50, and we got the other results. Person correlation not important here. The hypothesized mean difference zero because equal or not equal or bigger or not bigger, and degrees of freedom n-1 and 49. Statistics or Z, which is 1.987. One tail test is p-value is 0.026 and t critical value for one tail is 1.677. 40, not important for two tail because our problem is one tail test here. So we are interested on the p-value and t-test here. The t-test is 1.677, which is the computed one is bigger than it. And the p-value is smaller than 5%. The p-value is smaller than the 5%, so we must reject the null hypothesis in favor of the alternative hypothesis. So the one tail p-value is 0.026, which is less than 5% significance level. Therefore, we reject the null hypothesis, which says advertising in the Yellow Pages improves sales. Advertising in the yellow pages improves sale. That was the result which we got. Now, the population proportions, like what we talked about the population means, and now we talked about the population proportion, which actually is the same. But instead of talking about the mean, mu, we talk about the proportion p. But here we study one case, because when the sample size is big, it has one sampling distribution, which is the standard normal distribution. But when the sample size is small, the sampling distribution is very complicated, not a bit complicated, very complicated, and we will not study this. If the sample size is very small, then the problem will be very complicated, because the sampling distribution is very complicated and we will not study it. So we want to study now the hypothesis testing for the problem of the equity of two population proportion in the case of large sample size only, to use the approximation to the normal distribution. So we all the time for this question of hypothesis testing around two population proportion, we assume always that the sample size is big and bigger than 50. And we follow the same steps. Well, the problem will be easy. So the null hypothesis P1 minus P2 equals special value, which will take it 0. We will take it 0. We will not talk about other values. So P1 minus P2 is 0. So which means that P1 equals P2, right? And we estimate that. It is easy to estimate that from the sample. And we have this value. This is pooled. Estimated pooled P. Under the null hypothesis that the proportions are equal. So pooled, that means we calculated from two samples, right? Then this is the test statistic, and this is the pool. So it is easy to calculate in the case of large sample size, right? And this is the sampling distribution, and we follow the same steps as usual. So nothing too difficult and nothing nothing have any problem, right? Then in this case, we have also, as usual, once here two-sided test, and use Z statistic, and here one sample right hand tail, and here left hand tail. So this is as usual example, not different from the case of means or one mean even. It's the same. As long as we know the sampling distribution of the test of the point estimate, then we can set up the test and follow the same steps and get results. So we can use also Excel, or we can calculate by hand even without using Excel, Microsoft Excel. Now, we have example to illustrate this. Can illustrate all the procedure by one example, which we use by hand now to calculate everything. The example says, example 12, is there a significant difference between the proportion of men and the proportion of women who will vote yes on a proposition A? We have a proposition A for students, for legislative council, or whatever, and we vote for this proposition, yes or no. And we want to test whether there is a significant difference between the proportion of men and the proportion of women who vote yes. That's based on a random sample. In a random sample, in this random sample, we have 36 of 72 men and 31 of 50 women. 36 of 72 among 72 men and 31 among 50 women indicated they would vote yes. These are the two proportions for men and women. تمام? Who will vote yes? Then test at the 5% level of significance. For this hypothesis, the hypothesis is the null hypothesis P1 minus P2 equals 0. That's two-tailed hypothesis. So the alternative hypothesis is P1 minus P2 do not equal 0. So the null hypothesis means the two proportions are equal. The alternative, there is a significant difference between the two proportions. Now, because that's the question, we are not interested to know whether one is bigger than the other, but any difference. Is there any difference between the two proportions or not? Right? So that's the two-tail test, two-tail hypothesis. So the sample proportions, the sample, we calculate the sample proportions. The first sample proportion P1, which equals 36 over 72, which is 50%. And the second proportion for women equals 31 over 50, which is 0.62. So is that difference is significant to say there is a significant difference between women and men's votes? So we calculate the pooled estimate of the overall proportion. As we said, the pooled estimates is the estimate for the two calculated from the two samples, as we calculated under the null hypothesis. If the null hypothesis is true, if the two proportions are equal, then we can add up the two samples together and we calculate the P, pooled P from the two samples. So the people who, men who vote yes in the first sample and women who vote yes for the second sample over the two sample sizes, and we calculate that, which comes to 0.549, right? Now, after calculating the pooled population proportions, we can compute the test statistic Z, which follows the normal distributions, based on the sample estimates of the population proportions, which are P1 bar minus P2 bar, the pooled proportions. And according to the sampling distribution of the difference between two sample proportions, the statistic will look like that. Z equals the difference between the two sample proportions and minus the null values of the population proportions. Null values, which are hypothesized values of the difference between the two proportions of the sample of the populations, and over the standard error of the population of the sample proportions, which takes this form. That's from the sampling distribution of the difference between two sample proportions. And computing that, we got, as we stated, we calculated the pooled estimate of the proportion. We can calculate Z, which will be like that, and the result will be minus 1.3 1.31. And the critical values from the normal distribution tables, we get the critical values. Since the test is two-tailed test, then we should divide alpha, which is 5%, by 2, and we two halves of alpha, which will be 0.025 in each side. And from the table, we get the critical values, which is 1.96, and will be in the left minus 1.96 and positive 1.96 on the right. And that are the two critical values. So we find this, the computed or calculated value of the statistic Z is minus 1.31, which comes before the critical values minus 1.96 in this area. It's not in the rejection region, non-rejection region in this area. So there is no evidence to reject each node. So the result is that for alpha, so the significance level equals 0.055%, the decision will be do not reject each node, and we conclude that there is no significant evidence of a difference in the two proportion who will vote yes between men and women. So there is no difference between men and women in their proportion for voting yes for the proposition A. Now, next, another example for that. In this example, which is example 13, the personnel director, as personnel director, you want to test the perception of fairness of two methods of performance evaluation. You know, you have for personnel directors, they have performance indicators, and they evaluate the employees, and they want to know or to study the perception of fairness for the two methods of performance evaluation among the employees. Now, we have 63 of 78 employees rated method 1 as fair, but 49 of 82 rated method 2 as fair. At the 1% significance level, is there a difference in the perceptions? Is there a difference in perceptions on with the 1% significance level between method 1 and method 2 in fairness of the performance indicators or performance evaluation? So we have in this example we have two-tailed test because there is difference. It asks is there a difference. It does not ask whether one is bigger than or larger than the other or less than the other. Is there a difference in the proportions, two proportions? So the null hypothesis is that P1 minus P2 equals 0. And the alternative is P1 minus P2 do not equal 0. And we have here the alpha is 1%, 0.01. And we have N1 equals the first sample size is 78 and second sample size is 82. And according to the normal distribution table with 1% significance level, and we have two-tailed tests, so we divide 1% by 2, and we get 0.005 this side and 0.0025 this side. From the table, we get critical values, which is 2.58. So minus 2.58 on the left-hand side and plus 2.58 on the right-hand side. These are the critical values. So we have to compute also the test statistic Z, which will be, in this case, plus 2.90, which comes in the rejection region on the left-hand side here. It's greater than 2.58, which is in the rejection region. So the result is the reject H naught at alpha of significance level equals 0.01. The conclusion, we can conclude from this example that there is a significant evidence of a difference in the two proportion. So that is the result. There is a significant evidence in this. There is significant evidence that there is a difference in the two proportion, right? And that's all what we want, and we finished this unit, which is hypothesis testing. And the next unit also is also hypothesis testing, but it talks about the difference between or the equity of more than two means. Thank you very much, and see you again.